The objective here is to discuss fractions, decimals, percents, and their relationships with each other. So first we'll start with decimals into fractions. We have two different types of numbers in this category that we're going to talk about. We have rational numbers, and we also have irrational. The main focus of this first lesson will be on rational, even though irrational, I'm going to tell you what it is now. It'll really come out more in part 2 of this lesson. The idea with a rational number is that if you're talking, for example, about fractions and decimals, since that's what we're discussing, they convert very clean, very accurate conversion. The reason is because decimals are either terminal, meaning they end, a perfectly ending decimal, or they repeat, so they have a pattern. And not just a temporary pattern, a pattern that repeats in such a way that you can notate it and actually accurately represent the decimal. If these things are qualified, you're in the rational number section. That's where we're going to start with this lesson. The first thing I want to review with you is kind of basic, and it's not even something the author talks about much because there's not a lot of cases where it's super easy. But I am going to talk to you about an easy situation as far as decimals to fractions. So again, it's not super doable unless by hand, except with some easy examples like the ones we're going to look at. But I want to make sure that you do have some sense about you regarding going from a decimal number to a fraction. So the way to do that, here's a number, 0.3. Well, really we know it's not called 0.3, it's called 3/10, right? The way you can easily convert a nice decimal like this into a fraction is to just read it. It actually is exactly what I just said, 3/10. So 3 out of 10. And then of course you want to reduce that if you're able to. Another example would be 0.45, or more appropriately called 45 hundredths. Remember when you name these things, you're naming them based on the place of the last number, where that's at, the place value. So for this one, 45 hundredths would give you 45 over 100. And again, you reduce. Remember to reduce, all you do is divide by the same amount on top and bottom. So I'm going to divide by 5 on top and bottom to reduce this fraction to 9 over 20. So that's what the decimal 45 hundredths is equivalent to. Now, fraction to decimal. This is actually where the lesson really truly begins. This is where the author expects you to pick up in the homework. So fractions to decimals. I'll start with the same example we just had to begin with, 3/10, because that's actually a pretty easy one. Anytime you have something over a tenth or a hundredth or whatever, it's super easy because you just stick the number in the place. So for example, 3/10, just put the 3 in the tenths place. For something like 9 over 20, the one we just saw, if we were trying to go back to the decimal form, it's a little tougher, but nothing too bad, I don't believe. The idea is, well, first, if you can easily make the denominator a 100 or a 10 or 1,000, some unit of a perfect zero for the last digit, then you should do that. Some power of 10, I guess, really. But the idea here is if I times this by 5 on top and bottom, I get something over 100, what I wanted. I wanted tens, hundreds, thousands, etc. on the bottom, and on top I get 45. So with that, I again literally just write 45 hundredths. Remember that 5 goes in the hundredths place, so just make sure you write that there. And if you had to put a 0 in or something to space it so that 5 lands in the appropriate spot, that's what you do. Now your other option, since you can't always just do the whole times top and bottom by the same number, would be to divide. This always works, and this is generally what you will see people doing when they're going from a fraction to a decimal. So note that it always works. It's a good one to just kind of learn how to do. When you see a fraction, 9/20, it reads down. So this literally reads 9 divided by 20. So we have 9 divided by 20. This is the way we write long division in our country. We take the number on top, put it under the bar, and the one on bottom goes out front. We kind of, just like we read down, it's like we write it backwards. We write to the left. Let's see, to divide, you can remember that 20 doesn't go into 9, so I need to add a decimal. I'll bring that up top and put a 0 in. Now I can divide 20 into 90. That goes 4 times. 4 times 20 gives me 80. I subtract, I get a 10, and now that I have my decimal, I'm allowed to add zeros all day long. So I'm going to add a 0 here. 20 into 100, I get a 5. Let's see, 5 times 20, that's going to give me my 100. So I stop when I get a remainder of 0. Nice. So long division will always work for converting these. Another example, 2 nights. To do this, since I don't see an easy way of making this denominator into a 10, 100, 1,000, I'm just going to use long division since we know that will always work. So 2, the top thing goes underneath the bar, and the 9 goes out front. Again, to divide it, I add a decimal. 9 goes into 22 times. 2 times 9 is 18. Subtract, that gives me a 2. I can always add 0 once I've put that decimal there, so remember that. Now I'm going to drop it down. 9 goes into 20, 2 times again. And hopefully you're starting to see a pattern. We're getting 18 every time, so every time we subtract we're getting a 2. So we can see that this repeats. I can put a line anywhere over the number, and you only put it over the part that is repeating. So even though you could cover 2, 2, really just put a line over a single 2, and we know that that's the digit that's going over and over forever. On this one over here, when I write the answer, I can just stop it right there with the bar over the 2 in the tenths place. Either answer is okay. Another similar example. 5/11. With this, I'm going to practice my long division one more time. Add my decimal and my 0. Let's see, 11 goes in 4 times, giving me 44. And I subtract. I get 60 after bringing down that 0. 11 goes into 65 times. It gives me a 55. Again, when I subtract here, I'm going to get 5. Add a 0 and bring it down. Getting a 4 again. Once again, we're starting to get a pattern, aren't we? So we're going to get 5 again, because with that 60, we can see that we're starting to get something that's... So what you do is you can put the line over the repeating stuff. So we'll say 5/11 is equal to 0.45, repeating, or 45 hundredths repeating.